Good morning, students. Today, I am discussing about the design of fasteners. So, I am Munsi Rashidul Islam from JS College of Engineering, Department of Mechanical Engineering, and the subject that I covered today's class that is the design of machine elements, and paper code is ME503. Now, so last day, just we have discussed about the different types of keys and coupling design. Now today we have to discuss the design of fasteners. So first of all, you have to know what is fastener and how it is work and why the design is required for the different mechanical components. So let us see what is fastener. Fastener is actually a one type of joint which is mainly a non-permanent joint, and it is basically a permanent temporary type joint, and it is used to join more than two parts when the requirement is needed. It can be clamped or it can be assembled, and when the requirement is fulfilled, then it can be easily disassembled as per the requirement is done. That is actually the fastener. So lot of type fasteners design are included in your syllabuses, but few of the fasteners design that is already done. Now we can introduce the different types of fastener sample, and that fastener sample, the first fastener sample that I discuss in the next classes, that is actually the design of bolted joint, design of knuckle joint, design of quarter joint, the design of knuckle joint and quarter joint, and also the coupling design already completed in the last few more classes. So let us see what are the main objective of fasteners. So fasteners is actually a temporary base joint. So for that cases, some more requirement is needed to the actual cases of the joint. So joint means the joining method. Join couple of couple of parts that is actually connected in terms of some technical point of view. That is actually the defined medium. That defined medium may be in permanent type, maybe in temporary type. In temporary base fastener, that is actually included in just like nut and bolt design, design, threaded design, and knuckle joint design, quarter joint, and obviously the coupling design. So in the today's classes, so fasteners power screw connection. So fastener power screw connection means, power screw means the simple example of power screw that is seen in each and every point of the my life. That is actually the power screw that is actually used in automobile vehicles to lift the vehicles in up and down movement, and that is actually named as the screw jack. So it is actually the threaded base, and the outside diameter are threaded by the different angle. So that threaded angle that I already mentioned in most probably two class back. So that is actually the power screw con definition. So for helical thread screw, that is important to prevent the maximum power screw. The maximum power screw means the power screw actually transmit the angular motion to the linear motion. So if I rotate, if I put the motion, if I put the external load, the angular movement is transmitted to the linear movement. So for that cases, we can see that If we put the minimum effort, we can get the maximum output. That is actually, that's why we can see that one person, if I put the one vehicle, it is not possible. But if we if we put the power screw in below the vehicle, and one angular motion is given, so obviously the vehicle is moved in up and down direction. That is actually the function of power screw. So transmit larger and the produce axial load, and it is always desired to reduce the number of screw. That is actually the case of power screw, and it is actually the simple example of fastener. Now, definition of important terminology. Important terminology means uh, it is actually a case. It is actually a case that is the example of nut and bolt. So if I explain that the nut means there is no meaningful word. But if I tell you that the nut and bolt, so that word is very simplified. So here the hexagonal, if I see that the hexagonal bolt is there, and another side one nut is there. So if it's not, and in the cases of the hexagonal bolt, the external thread are there. So external thread means the thread length, thread angle, sunk means obviously the bolt length, and obviously knot is there, and washer means suppose below the bolted hexagonal head of the bolt, one washer is there. Washer is actually used to absorb the shock absorb, to absorb the shock that is actually used as the maximum erosion of the bolt. So that is actually the case of the case of the power screw. Now the few more points is there, that is actually measured dia. That measured dia is expressed in the figure, that is small d. Next is minor dia, that is actually may expressed in dr. Mean dia or pitch diameter, that is expressed in dp. Lead obviously in I notation, and the other parts are in just like a root, chest, etc. Thread length, so all, and obviously the thread angle. So all the notation that is actually expressed in this figure. So first of all, now what is measured dia? Measured dia, it is actually measured in this figure. In this figure, it is actually measured as the crease to crest of the thread. Crest to crest of the thread means suppose the uppermost portion of the crest to the next crest distance, that is actually mentioned as a major dia. Now next is minor dia. Minor dia, it is measured from the root to the root of the thread. Root to the root of the thread, that is actually mentioned as a minor dia, and it is called as a root or chord dia. It is also called root or a chord dia. And next is pitch diameter. It is actually the distance between the two diametrically opposite points, and obviously in the figure that is mentioned on the imaginary cylinder, and point to which the bolt of the thread to the axial space between the two space of the two adjacent thread. So to between distance between the two adjacent thread, that is actually called as a pitch. Suppose first thread and second thread, the some gap is there. That gap is called as a pitch diameter or pitch of the thread. Next, pitch diameter. Next, p. What is pitch? Small p. What is pitch? It is the distance. Actually, it is the distance m- measured to the parallel to the long axis of the bolt and between the two similar points of the adjacent thread. Between the two points of the adjacent thread, and in the simple start thread, the knot moves in one revolution. That means it transmit one linear distance to the equal one point of pitch, point of one pitch. And now next, what is bolt? Now it can be discussed more or less meaningful word that is called the bolt, and bolt may be called as a external bolt, internal bolt. So in external bolt cases, the threading point are in the external diameter of the shank, and in internal bolt the threads are in internally with the core diameter or the shank diameter. Now the next point is single and double threaded screw. Single and double threaded screw. Single and double threaded screws means the when the threads are in single point, and single point means suppose one point is there, and suppose that, if I see the figure, that figure is called the total pitch diameter. Total pitch diameter are in parallel to the next pitch diameter. So that is actually the simple form, and there is no complexity because it is to the straight point of view of the core diameter, pitch diameter to the next pitch diameter. But if I see that double threaded, here there is angle. There is a angle, some certain angle. That angle create a parallel thread. That parallel thread is actually the double threaded, called as a double threaded. That double threaded actually in the stronger and move faster because it is actually a strong and moves faster because it is more torque is required to open and close the actual thread position. So that is actually the single and double threaded screw. And next, screw designation. Screw designation means suppose some certain point of view screw designation are there, means some screwed value. That screwed value is actually some screwed value is there. That is actually the screw point of view. That screw point of view means it is a acme thread angle, depends on the thread angle that is based on the acme thread angle. So acme thread angle, United Nations standard means UNS standard, some certain angle is there. In acme thread, total angle between the crease to the root, and that angle vary to the 29 to 30 degree angle. But here we can see that the 30-degree angle is there, and that 30-degree angle is actually based on the minor dia. That minor dia is expressed in the root of the screw. That is actually that expressed in dr. And obviously the pitch is the actual distance between the two mm, peak point of the thread. That is actually distance between the one thread to the another thread distance, and that distance is called as a pitch of the rivet. Now next, fine thread UNF. Fine thread UNF means, suppose, course thread designed by UNS. UNS that I already explained in the next previous slide. United National Threads. So United National Thread, fine threaded UNF, it is more resistant to the loosening because of its more helix angle, small helix angle. That small helix angle means it is actually more require power is required, or more torque is required to prevent the resistance power of the thread conditions. Now, now they are used when the vibration is present, and obviously the vibration, here vibration is minimum. So for that cases it can be used as a best optimistic way when the maximum shock absorption is required. Now, class of screw defines of fits, and the fits may be varied on the tolerance limit, and the most commonly used of the class is that is actually class 2, and class 3 for very precision application, just like the 1 in 12 and etc. Threaded system, and that threaded system obviously in the mentioned in previous slide, that is actually the internal threads and external threads. So based on the internal and external thread, most of the threads that is basically used for the power screw, or that is the external thread that is actually used. And metric thread M20 into 1.5, that means the pitch is 1.5. um, M means, if one clarification is required, because somewhere someone is asked you the one question, if I know on the M10 into 1.5, that means what is this, what is this. So for that cases you can, you have to know that, and the M20, M10, and 10 means obviously the diameter of major diameter, and M means obviously metric thread, and 1.5 means the pitch. That is actually the expression of M10 into 1.5. Now, next. Now, here are the different types of here are different types of threads, that is actually as per the requirement, square and acme threads. So square thread is there, and if you see that the angle, pitch, and etc., and prepared pitch for the acme thread, that is actually expressed pitch diameter, basically D means diameter of the pitch acme thread, and P means pitch. So that is actually the uh, actually the table chart. That table chart you have also available in the, you have also get the data in the design data handbook, and that is a typical type um, acme thread system, and obviously the square thread system, and it is the actually mechanism of power screw. That mechanism, if you see that, uh, uh, this area, if you see the, if you spindle, if you rotate the spindle, the rotating rotational movement converted into the linear movement, and it is copied from it. This figure is copied from the Tata McGrail books, and it is a actually the typical figure of this book, and just we can get this figure in this book, and it is a basic type of figure, and a power screw is function in the above mentioned um, mechanism. Here are the full mechanism of the power screw. So already I explained that the all the parts of the body are in this. Here the outside part of the figure is called as base, and I mean, inside the base, here are the screw is there. That is actually a threaded portion. That threaded portion outside the shank, and above the screw one portion is there, that is a thrust collar, and uppermost portion one knot is attached. That knot is attached with some certain angle. That certain angle obviously you can put. And here in this figure, just right hand portion one figure is there, that is a small hollow portion. That hollow portion is actually the spindle portion. So if I put this in this spindle in rotating rotational movement or rotational moving conditions, so that is that total mechanism may be up and down movement, and that is the requirement. And one more portion means if this threaded portion up and down movement, so obviously the level of load obviously in downward direction, because it is actually power screw, it is actually used to lift or down the any type of motion. But to lift the motion means the body weight of the vehicles are in the downward direction. That's why the total load is applied in downward direction. For that is the figure to change the angular motion into the linear motion, and total mechanism are already explained. Now that is actually the what is the relation between the applied torque and the power torque, and obviously and the force is needed to relate a mechanism. So obviously the that is actually the figure and conditions, and taking from the Tata McGraw book. uh, that's why the relation may be noted down, and not and bold how it can be worked in combined conditions. So that is the basic fundamental process of to find out the find out the maximum mechanism of the power screw. And that is actually the torque for the single thread flat thread, and that mechanism is actually you can get the radial type load and the linear type load. So radial type load and linear type load, it can be calculated as per the conditions available in the some certain angle obviously, and total applying force, and that force is actually the external force. If I put the equation of the shear stress equation, that is actually the tau is equal to 16 t by pi dq. Here t is the maximum torque, and bearing stress also be available. And if the total bearing stress is engaged, so you can see the maximum shear stress with the base of the different type of power screw angle. That power screw angle may be depend on the acme thread, square thread, etc. Loading to the fasteners and their failure of the consideration. So a lot of failure process are needed, and that process is actually required for the different types of cases of the total body. So that body may be fail in the different conditions. That different conditions means the power screw, the here the four parts is mainly four parts is there: nut, shank, uh, not sunk dia, major dia, minor dia. So most of the cases, so failure will occur on the knot portion, and obviously the sunk dia portion. So knot portion may be failed due to the compression, and uh, obviously the sunk dia fail may be the shear stress induced in the uppermost portion of the sunk. Now let us see the next slide, that is actually uh, slide. Uh, uh, Now it is actually if you see that the one hexagonal thread is there, that hexagonal thread is under the body parts when the two parts are in connected. But if you see that here are the parallel threads are there, and the lower portion of the thread is actually attached to the lower mm, part of the body, and upper part of the body is attached to the hexagonal thread. So that thread is fully and tightly fixed with the two parts. But here some question will arise: how it can be tight or ear hole reduced from this joint? So it can be fixed or it can be tied properly if we use the one washer. That washer is below the hexagonal thread. One certain washer portion is there. So if I put in tight portion, so obviously the total threading conditions will be tight and no losing part will be there. So for if we put the tightly fixed, so second time means when we disassemble the parts, so more effort is required to disassemble this and this part. So for that cases, we can tie it with proper and limitable way. Otherwise, if we want if once it fixed properly and some certain um, gap is there, means suppose duration will long, so some moisture, some waste portion will gathered near the bolt. So for that cases, more effort is required, and maybe if when it disassemble, if we apply the maximum effort, it can be a threading conditions, and that threading conditions mean it may be failed in the head portion or the lower portion. So for that cases, it is very serious to assemble the two parts when the two parts are in an engaged position with the help of the washer. That is the conclusion part of the power screw. So now next classes we can discuss the next topic. That topic may be in bolted joint or maybe in riveted joint, design of riveted joint. So thank you.